Welcome back, everyone. In this video, we'll be going through the first problem for the finding area between two curves. Now, as you can see here, we want to find the area between the two curves, y equals 3 times cosine of 7x, y equals 3 minus 3 times cosine of 7x, and x must be between 0 and pi over 7. So this is one where it actually gives us the a and b, and then it gives us our two functions. But the thing is, we don't know which one's the top and the bottom, which is why there's a hint here and why you should always do this when you're finding the area between two curves, and you should graph them. And once again, with graphing, the main point of graphing is so you know the kind of shapes you get, but there's no reason with all the technology we have to just graph these by hand. We have y equals 3 cosine of 7x. And don't worry, we'll adjust the everything here. So, and also y equals 3 minus 3 times cosine of 7x. And one thing is that we only care about x being between 0 and pi over 7. So if I click this little toolbar here, I can make the x values go from 0 to pi over 7. Now the step size, because it's probably better to figure out, the step size in terms of pi, because we have 0 to pi over 7, you can do this where you make the step size maybe pi over 28 or something. Really, let's do, gives us a pretty messy decimal. What if we do pi over 21? That works pretty well. So the reason I chose that is I just took the pi over 7 and I wanted to divide up into equal lengths. So, and 7 times 3 is 21, so pi over 21 works well. Pi over 28 just gave messy decimals, so this seems a little better. But the reason I haven't scrolled out at all is because I have exactly the x bounds that I'm given. This is x equals 0, this is x equals pi over 7. And what you want to notice here is that we kind of have the situation of them crossing. The red graph is the graph y equals 3 cosine 7x, and the blue one is the 3 minus 3 cosine 7x. So when we set up our integral, you'll notice that they cross, and they cross at x equals pi over 21. So I'm going to go ahead and write down in words what we have. From 0, x equals 0, where it starts, to pi over 21, the y equals 3 cosine of 7x is on the top. So from x equals 0 to x equals pi over 21, y equals 3 cosine of 7x is on top. All right, what about after that? Well, for the rest of the way, all the way to pi over 7, we don't care what happens after that, so I'm not going to scroll out. But after this, the blue graph, which is 3 minus 3 cosine of 7x, is on the top. So from pi over 21 to all the way to pi over 7, the 3 minus 3 cosine of 7x is on top. Now, why am I pointing this out? Well, remember the formula for the area between two curves. It really matters when you set out which one's on top. If you know which one's on top, you automatically know which one's on the bottom. So the best thing you can do here, absolutely without a doubt, is set up two integrals, one for this and one for this. And the thing here typically is that you don't want to try to set them up together and then try to combine them in any way, because really you normally cannot combine them in any way. If there was a way, then we would do it from the start. So we really need to just do one thing, and that is go ahead and graph it. Sorry, not graph it. Set up each one and do them individually. So I'll call this one 1 just to keep it labeled. And we'll do the integral 1 first. So the area of 1 here, well, our bounds on x are from 0 to pi over 21. And then we do top minus bottom inside. The top one is 3 cosine of 7x minus the bottom. Now, because I have an attachment here for the bottom function, which is the other one, I'm going to put in parentheses 3 minus 3 cosine of 7x dx. And just remember the general formula you have from a to b of top minus bottom. So if you figure out which one's on the top on a specific interval, you just set it up and go. All right, and now simplify the inside. You can distribute the minus sign through here. The minus 3 cosine 7x gives us a plus 3. That means there's 6 of them because there's 3 cosine 7x and then 3 more. And then we have minus 3. And now what do we want to do here? Well, it's up to you. One thing you might notice here is that we do have to do some type of substitution method because this inside isn't just x. And one thing that you'll notice very quickly is when you have like a trig function or an e or anything with just a number times x in it, the same pattern is always going to happen. I'm going to go through and do this one. And then when we do the second one, we'll go ahead and do that shortcut. But I'm going to have u equals to 7x because I do not have a way to represent this otherwise. And then what is du? Well, du, we do the derivative times dx, and then it's better to plug in or solve for dx, so we can just plug it in directly, divide by 7. Now, one thing you want to make sure you're doing is we're not actually plugging it in yet, because remember this dx is only being substituted where we did the u. So we should do one thing before I actually plug in what u and dx are and break up the integral. So that's just something that's important to remember with substitution method, is unless if you're substituting in the entire thing inside, which we're not substituting in the minus 3 part, you want to make sure you do not substitute in the whole thing. Now you can, but then you have to be very careful. So it's better just to break it up. We have the first one minus, and then we have the second one. Right, so let's go ahead. Now we can plug in the first one. The second one we can actually integrate already because it's just a number. So in the first one, we can bring the 6 out, integrate from 0 to pi over 21. We have cosine of 7x is what we made u, and then dx was du over 7. And then we have the minus here, and then when we integrate this, it's just a number, so when we integrate 3 dx, we get 3 times x, and then these are x bounds. I know we didn't write x equals, but I'm just going to convert them back all the x from 0 to pi over 21. And now it's up to you what you do. I pretty much wait until the end to plug in because I know I'm going to have to plug in the same numbers in here anyway. I'm going to go ahead and bring this 7 out. One thing I'll mention here is that what happened when we made this substitution is we ended up dividing du by the 7 because that's our derivative of 7x. And if you add 4 here, u equals 4x, then you would divide by 4. So that's going to be a common theme when it's just a number times x, and it's very helpful. We got 6 over 7, the integral from 0 to pi over 21 of cosine of u du. And we have a formula for this, so we can use this, minus 3x from 0 to pi over 21. Now, one more step, the antiderivative or integral of cosine of u is just sine of u. It's positive. But remember, these are x bounds and we have u. Let's go ahead and just write x equals, just for clarity here, minus 3x from 0 to pi over 21. And now we plug back in what u is, which was 7x. We got 6 over 7 times sine of 7x. Now because it's x, I'm just going to not rewrite the x here and just write from 0 to pi over 21 minus 3x, 0 to pi over 21. But sort of the point here is that because you're going to plug in the same numbers, instead of thinking about doing it twice, you can just do it once. And now to finish this, we have 6 over 7 sine of 7x minus 3x. And I just want to plug both of them in at once. So 0 to pi over 21, I want to plug them into both spots at once. I don't want to do it separately. Now we can finally plug it in. So we got pi over 21. 6 over 7 sine of 7 times pi over 21, which simplifies pi over 3, so we'll take care of that, minus 3 times pi over 21. Okay, that's our pi over 21, minus, and then plug in 0. We got 6 over 7 times sine of 7 times 0, minus 3 times 0 is just 0. Now, luckily for us, we actually get 0 here anyway because sine of 0 is 0. And then sine of pi over 3, because that's what this is, sine of pi over 3, that's the square root of 3 over 2. But when we go ahead and plug it in now, we are left with 6 over 7 times sine of pi over 3 is square root of 3 over 2. And then minus, well, the 3 and 21 make 1 over 7, so minus pi over 7. And you can do one more thing, I suppose. You can cancel the 6 and the 2 out. This becomes a 3, and this is a 1. So we've got 3 times square root of 3 over 7 minus pi over 7. Now, unfortunately, this is just the first part. We still have to do a second integral. But if you can do the first part, the nice thing is that when you do the other one, it just pretty much works out the same way. You're just flipping the order because the top and the bottom switch. All right, so let's go ahead and do it. I will label this one as number 2 just as a starting point so we can keep track of it. And let me leave that in view here. So number 2 here, we've got to do the integral. It's from pi over 21 to pi over 7. And then the top one was the 3 minus 3 cosine of 7x. Minus, and then what's the bottom one is the other one. You can just look right here to remind yourself. The bottom one is just 3 cosine of 7x. Because that's just one term here, we don't have to really worry about distributing to anything because it just goes to the thing we're subtracting. So we got that dx. And when you simplify this, what you'll notice here is that excuse me, this is exactly the same as this, but opposite. What I mean by that is you get 3 minus 6 cosine of 7x. And you can really take advantage of this when you compute the second integral. And this can really be a big time saver. Now you can go through and do all the same steps that we did because you technically need to do use substitution and everything. But because this is the same integral just reversed, as far as, notice here, this is just the minus of this. If you factor out the minus, what I'm going to do is just make it look exactly like this integral. So at least until I get to this point, when I plugged it in, I can actually skip all this because it's the same formula when we do the antiderivative. So we factor out the negative, and we get, I'm going to take the negative inside first. I won't do this in too many steps. But when we take out the negative, what taking out a negative does is it reverses the order here. And if you don't see it right away, imagine factoring this back in. We would have negative, or distributing it back in, you have negative 6 cosine 7x minus plus 3 because it's the double negative, which is exactly what we have here. Right? And then you can bring the negative outside. And then on the inside, we have 6 cosine of 7x minus 3 dx. All right, and the point here is you could go through and do this entire thing. So you would say, okay, I need to use u equals 7x to compute du, split it up, do all these steps, do all the antiderivatives, and then combine them back here. Or you can make your life a lot easier. Let me go ahead and still give myself a little more room, but we can make our lives a lot easier because all we have to do is keep this negative sign out front. And then when we integrate the inside, so when we integrate this, we get exactly this out again because it's the same thing. So we're going to get 6 over 7 sine of 7x minus 3x. So I'm putting this in big brackets just to indicate that we have the negative sign here that's staying out front. But when we integrate this, so imagine if this was completely gone, we would get exactly this. And then our endpoints that we would plug in are just different here. So we got from pi over 21 to pi over 7. Once again, if you're not comfortable with that, go through the steps here. But you're basically going to start here and do the same exact steps until you get to here. But it is good practice if you need extra practice. Right. So you can distribute the negative sign back in, probably makes it a lot easier. Or you can just leave it out front and then plug in your numbers. I'm going to distribute it back in. So we've got, when we take it back in, it's just going to flip the order again. So we get 3x minus 6 over 7 times sine of 7x from pi over 21 to pi over 7. But at this step, you definitely want to just go ahead and plug in the numbers. So we want to take pi over 7 and plug that in. We get 3 times pi over 7 minus 6 over 7 times sine of 7 times pi over 7. So that's plugging in pi over 7 minus, and then we plug in pi over 21. We get 3 times pi over 21 minus 6 over 7 times sine of 7 times pi over 21. And now what do we have here? This is 3 pi over 7 in front. And this is just sine of pi, which is 0. So this is 0. And this is the same angle as before. This is pi over 3. So this equals sine of pi over 3 is square root of 3 over 2. Right, so when we go ahead and do that, we have the minus. And then when we distribute the minus through, this becomes pi minus pi over 7. And then minus minus becomes a plus 6 over 7 times the square root of 3 over 2. Right? And then when we simplify this, we'll get another number. So luckily for us, we can simplify the first two things pretty quickly because they're already over 7. 3 pi over 7 minus pi over 7 is 2 pi over 7. And then plus, this is the same thing as before. You can cancel out the 6 and with the 2 to make a 3 and a 1. And we get plus 3 times the square root of 3 over 7. Right. Now what we have here is we found the area of the two parts. To get our final answer, what should we do? Well, let's just revisit the picture so we can just make sense of it real quickly. We found the area of this part. We found the area of this part. Now to find the total area, we add them together. So let's go ahead and do that. Go ahead and add these together. And once you add them together, your final answer, that is your total area. Let's go ahead and see what we get. We add them together, we get 3 times the square root of 3 over 7 minus pi over 7 plus, and then we have plus 2 pi over 7 plus 3 times the square root of 3 over 7. Now these are all over 7, so you could make them all on top of one denominator of 7. You have 2 pi minus pi, which is 1 pi. And 3 square root of 3 plus 3 square root of 3 would be 6 square root of 3. And that is the area between these two curves. Now, if you're ever stuck or if you're ever unsure if you set up correctly, so maybe you figured out which one's the top and the bottom, where they intersect and everything, but you get it backwards, what will happen is you'll get a negative number for the area, and that'll tell you I messed up. So one thing we can do is just check. Maybe I looked at this too quickly and I thought, oh, this one was on the top, but I was looking over here and actually wrote the wrong formula. Well, for our area 1 and area 2, they both need to be positive. So we can just check this real quickly. 3 times the square root of 3 divided by 7 minus pi over 7. And you see that this is positive, so this is good. If we mess it up, it would be negative. And then this one's definitely positive because we're adding two numbers together that are positive. So we didn't mess that one up. but that's pretty much the only thing you can do to really check. Now, realistically, most problems you only have to set up one integral because there will just be a top and a bottom. And in that case, you really only do the first part here and you'll stop once you figure out that area. But I wanted to make sure I show you that it is possible that the top and bottom switch. And when that happens, you do have to set it up and do two different integrals. Now, if you do want to check your answer here, Wolfram Alpha, it doesn't do well with typing finding the area of, but if you do integrate the absolute value of just one of these minus the other one, it'll actually work for you. So if you write integrate and then ABS for absolute value, I have the one function here. It doesn't matter which one is on the top and bottom because it switches anyway. So y equals 3 cosine of 7x minus the other one, which is y equals 3 minus 3 cosine of 7x. And then I want to put from x equals 0 to x equals pi over 7. You'll notice it'll set up the integral exactly like we would want it with the absolute value. That's pretty much telling Wolfram Alpha to find the area. But when we do that, you can see it does give you the answer 1 over 7 times 6 square root of 3 plus pi, which is exactly this. They just factor out the 1 over 7. So it does work. And pretty much when you do the absolute value, the area visually can look kind of weird, but it works well for us because that's the way Wolfram Alpha can actually compute it. So if you wanted to check your area, there are probably other calculators that you can find the area between two curves of, but Wolfram Alpha can do it as well. You just have to do this absolute value. If you forget the absolute value, then what happens is it doesn't take into account which one's on top and which one's on bottom, and you'll get sort of like the positive part, but then the negative part, and it won't work out perfectly for you. So just beware of that. The absolute value is absolutely necessary. Right. Now that problem is a little more lengthy than the next one we'll do, but the point here is that really you can do the area between any two curves if you just follow this format. And just keep in mind that when you graph, if there's only one section where it's on the top and bottom, you only have to set up one integral, and that's great. But I'll see you in the next video.